that kind of sums up my evening. We started a little bit late and we have a few technical problems before we start, right? So now we have all of the technical issues out of the way, we can actually start work on the project. So, as I was just saying, we are working on the Fender-style Jazz Bass that we worked on last stream. And we designed the body of the bass in Fusion 360, and we're now moving on into the CNC toolpath in preparation to machine our first test blank. The idea is going to be that we're going to use some inexpensive materials to make the blank before moving on to the more expensive woods that are more associated with guitar building. As I said in the last stream, this is the first time I've done any sort of musical instrument, and yeah, this is going to be interesting. All right, see you Waffles, welcome into chat. How are you doing? Right, the sub count is looking good. Yeah, it is. I admit, it is very nice to see that number there. Okay, without further ado, without any more technical disruption, let's see if we can get into this. So here is the body that we modeled in last week's stream, and we're now going to, like I say, prep this up ready for machining. Now I included some of the radiuses on the edges of the body, but we're not going to machine those on the CNC, and for one very good reason. I can run a palm router with a roundover bit in it around this body relatively quickly, and that will be far less time than I can do an operation in Fusion 360. So I'm going to remove or suppress the radiuses on this body. See you Waffles, you keep at it, buddy. You keep at it. You'll get there. It's taken me quite some time to get to the 1,000 subscriber mark. And for those of you watching on the replay, this live stream is going out on the day that I reached 1,000 subscribers on YouTube. So a little bit of a celebration right there. Brings a smile to my face, and I have so much gratitude for everybody who has supported me along my journey. But as I said in a post earlier today, the view is great, but I'm just passing through. I want to see how far I can go. Was you the 1,000th person Road Rally race? How are you doing? I don't believe so. Okay, so I'm going to right-click my feature here, and I'm going to suppress it. And that just squares off the edges of the blank. I hope so, Dimitri. I hope it is the first of many. Are we saying there's been a change? Or are you saying, no, there's no change? No, see Waffles, I'm reasonably confident that that wasn't the last sub. In fact, I believe the last person, the person that took me over to 1,000 subscribers, is somebody who appears to be a luthier. So All good. All good. All right. So let's make a start. So I'm going to create a new file in here, and we're going to call it, save. We're going to call it body CNC setup. So what I'm doing is I am isolating the files that I'm using to actually do the machining. I've got design files and then I've got machining files, and keeping them separate for me, it keeps things in a nice, neat, orderly fashion. Something that I do actually need. You think I've scammed you, Road Rally Race? Okay, so let's bring in the body, and we're gonna just let that sit right there. I have taken the liberty of bringing in the CNC representation of my stock, and I'm going to bring that into this file, and I'm going to align it. Tell you what, you cancel that for one moment. Bring this in, and hopefully I can. Okay. So we're gonna go down minus 45. There we go. So this is my blank that I'm going to be using for my CNC setup. Silent mode. Welcome in. Yeah, if you like this video, please give it a like. It helps the channel a lot. It gives YouTube some engagement data about people who are coming into my live streams. So now we have our stock and we have our body. We're going to go into the machining of the body. So we're going to switch over to the manufacturing section of Fusion 360. So I don't know how many of you people know, but Fusion 360 is a CAD and CAM software. So CAD, it enables you the computer-aided design. You can create your 3D models using various tools, whether that's solid body, whether it's sheet material, whether it is surface modeling, all of that sort of cool stuff. And it's incredibly powerful. The other side of Fusion 360 is the CAM side, which is computer-aided manufacturing. And what we can do is we can create files that we're going to send to a manufacturing machine. And in this case, it's a 3-axis CNC machine. And we're going to create the tool paths. We're going to create the movement instructions for the machine to carve out this body in a piece of material. So the way that we do that is we start with a setup. So we need 2 setups. Let's think of this ahead of time, right? We need 2 setups, one for the front side and then one for the back side. So we're actually going to take the blank and we're going to flip it over and we're going to machine the other side. It's a 2-sided operation. So let's create a new setup, and we do that by right-clicking setups here and new setup. And in here, we're going to go to the machine. And the first thing we're going to do is we're going to tell it that we've got a generic 3-axis CNC machine. Okay, so we're going to select that. Now, in Fusion 360, it's got loads of support for different industrial type machines. Loads and loads of industrial type machines. And you essentially can... Oh, what's it doing? Saving the machine. Got me thinking. So So you can actually represent like a Tormac industrial machine. You can see the jaws on the Tormac, you can see the machine head, and it gives you really, really like fine control over things. And I guess when you have that level of information, it can help you avoid crashing your machine into your set of jaws and stuff like that, providing you've got the machine set up properly. For me, I've got a generic 6040 CNC machine, which I'm in the process of restoring. It is in an operational state, and it is fitted with a, I think it's a 2000 watt water-cooled spindle. And I love this. I love the water-cooled spindle by comparison to a router, because the amount of noise that the spindle gives off is incredibly low by comparison to a router. So the first thing we need to do is set up our origin, and we can choose to select our origin from our model. And we're going to select this model, and we're going to select, let me see here, orientation. I tell you what I have done. I have missed a step. So let me cancel this for a moment. If I come back into design, I'm going to orientate this so that is more beneficial to my machine. Dimitri, I hear you. I wish I had more room than I do, but I guess I got to be grateful for what I've got, because I know there's a lot of people out there with less. So okay, I'm gonna orientate my material this way. So this vertical axis is my y-axis, the horizontal is my x, and if I was to zoom in and out, I'd be zooming in and out against the z-axis. So let us go back into the manufacturer side of things again. Let's create our setup. All right. So we're gonna select this point here in the top corner. And select a point on this body. I want to try and select now, wouldn't you know it, it is not behaving the way I want it to. You'd think, right? You'd think that You'd think that I would have actually practiced this. There we go. Perfect. Dimitri, do I know you somewhere else under a different name? Because if I do, I'm unaware. Okay, let's go to the stock. We've got offsets. We're going to take those offsets off because these offsets are not required because the material is representative. You're copying me. Excellent. All right, so now we have our XY location set up on the corner of our stock. This is going to be my XY 0 point on the CNC machine. And you'll notice I've selected the top of the stock. And that is going to be, I'm going to bring the tools down to the surface of the stock. And I'm going to zero that out to make sure that I'm in the right place. All right, so next up, what we're going to do is we're going to start doing some operations. And the first operation that we want to do is we want to do a boring operation. Okay, so I'm going to select these holes. And these holes represent registration pins. These registration pins are essentially going to be used so that when we lift our material off the workpiece after it's had one of its jobs done and we flip it over, we have an accurate representation in 3D space where that exists. All right, so we're going to select the tool, and I'm not going to go into the tool library setup much, but essentially you can either pick from a list of tools that Fusion 360 knows about. And if Fusion 360 doesn't know about your tool, you can come in here and you can create your own. So this is a little bit of a mix between my own tools and some of the tools that I've got from the library. So the first one I'm going to choose, I'm just looking through my list here, is going to be my flat end mill. I'm going to select that. And this is a 4-flute downcut, I think. Okay. So we're going to click on OK. And now if I right click, and I am going to simulate. And when I run the simulation, you can see that, let me just slow that down a little bit. You can see the movement of the machine, right? It's going to bore down this hole here, over there, and over here. Oh, you got me thinking now. This is going to be a conundrum. Because that has so many different connotations to me. Okay, the important thing to make sure is when you're setting up your own tools is that you have the shaft lengths and the bits that protrude below the chuck of your machine, because you'll notice we're getting pretty low in the hole, right? This is quite a thick piece of material. And I'm pretty much pushing the machine to sort of the maximum sort of limits that I have available. So I need to be incredibly careful here that I don't crash my machine into my stock. Now, Fusion 360 is pretty cool. If you put the details into it, it will highlight where your tools are going to crash. So not only is this toolpath going to be used to machine the registration holes in the material, it's also going to be used to cut the registration holes in my wasteboard. So what I'll probably do is bring this piece down to the tool down to my wasteboard, set it to 0, raise it up by maybe like 40 millimeters, and then bring it back down. So it'll only go like 5 millimeters, 10 millimeters, whatever I choose, down into my wasteboard. But that's kind of a workaround. Okay, I'm going to exit the simulation, and these are my registration holes. Awesome. So the next thing we're going to do is we're going to surface this material so that it is nice and flat. So we'll choose surface from the 2D panel. We're going to select our tool, and we're going to use a surfacing bit. So this is a 4-flute You got me thinking. You have so got me thinking right now. Okay, so we're going to run the surface, a basic surface pass on here. And what this is going to do is it's going to make sure that this surface is flat and parallel to the wasteboard. Now, I can already see a problem with that in that it's going beyond the material, and that is bad because this piece of material is pretty much the size of my my bed. So I'm going to need to edit this, and let's see what we've got here. So I'm going to choose this face, and we're going to say start on the inside. We'll click on OK. Click on OK and just have a look. Okay, we can see that that is still going past. Dimitri, I'm still at a loss here. You're gonna tease me. Am I gonna get it by the end of stream? That's gonna be the interesting question, right? Okay, what do we got? Use inner loops. Start from the inside. Start always inside. Click on OK. Click on OK. Ah, okay. So we've got a challenge here. We've got a challenge in that if my machine had a wider X, then it wouldn't be too much of a problem. So I need to figure out how I can manipulate this face to operation. Yeah, right. Yeah, you're not wrong. Okay, let's get rid of that. Let's get rid of that. Let's try this again. Selection. I'm going to select this. Select same plane. We're going to do inner loops. Start on the inside. We shall click on OK and then OK. Will it now? Right, okay. Let's see what this does now. I don't think this is what we want, but it's different. All right, so if I simulate, this is really cool because we can simulate our job before it goes anywhere near the CNC machine. Awesome. Okay, so that's just going over the boreholes. So that's definitely not what we want, but it is a change from what we had previously. You and me both. Okay, I am in the process, right, of trying to figure this out. So let's try a chain instead. So we're going to choose that. 4 edges. We'll click on... It's not giving me the option to... It's not giving me the option to choose inside. And it's still going beyond the bounds of the machine, right? So essentially what's going to happen is it's going to crash. Every time it goes X and Y, it will crash. So we don't want to do that. So we do need to figure this out. And once we figured it out once, we should be able to repeat this time and time again. Let me try... Okay, I can live with that. Can I? Not really. Because the whole blank. You know one thing that'll give it away in a second. Oh dear. Hang on. Hang on. Buying water towers. Ah! Ha! Right. Right. Bing, 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 bing. Yahtzee, we have a winner. All right, I'm with it. Yes. I'm like, oh. Right, I'm going to create a sketch on this. We're going to capture the position, and I think this might work. I am cheating, so let's see if I can cheat and win. We're going to do an offset of this, and we're going to go minus 12, which is the diameter of the bit. We might need to go to 24 millimeters, but we shall see. Right, we'll finish that sketch. Let's just hide these bodies. And what we're going to do is we're going to extrude this. And I'm cheating, right? Because I'm in the middle of a stream and things aren't going as planned. So I am thinking around the problem to make it do what I want it to. Minus 45. Right, so there's this. It's essentially another stock, another piece of stock that I'm going to use that essentially we can game the system a little bit. So if I now right click here and we edit, I'm going to hide. Oh, the bed is already hidden, which is good. So if I now select, I get rid of that and we select that in its place and we click on OK. I'm going to let it just do its thing. Okay, so it passes over, but it's still on its reverse, on its U-turn. It's still outside the bounds. It's an improvement, but it's not where we need it to be. So we're going to go to minus 24 in that sketch, as opposed to a minus 12 offset. And what I'm hoping is that that will now give us the bit that we want. Okay, let's just reorientate ourselves. Now, if I right click and we generate again. All right, you can now see that we're inside the bounds, but we are not all the way up to the top. So let's fix that. We're getting there. We're getting there. Okay, so if we edit the sketch, I'm going to bring in the bed. I'm going to project this edge here. And I'm going to project this edge down here. And I'm going to draw a line from this location to that location. I'm going to do the same over here. Okay, and we got a selectable item, which is perfect. I'm going to do the same here. Now, I'm sure if there's any machinists watching this video, you're going to say, oh my God, he's doing this completely wrong. Well, that's because I'm not a professional. I am an enthusiast. And as an enthusiast, I can say these things. Right, okay, so I'm now going to extend the bed. I'm going to extend the bed, or extend the blank to the bed. Okay, perfect, perfect, perfect. There we go. And now let's go back into our manufacture. And if we regenerate the facing operation. All right, we now have a facing operation which stays within the bounds of our machine. It will not crash, but it does give us a nice flat surface. Let's simulate that just to make doubly sure that we're happy with it. Right. I agree. I do want a larger CNC so I can do this. I know that when I get to the neck that I'm going to have some challenges with the neck, right? Because I know it won't fit. So I have to figure out what we're going to do about that. Anyway, that being said, we've now got our facing operation. We can now start getting into the meat and veg of this. So let's hide the body of the bed and just bring in our guitar. Now what we're going to do is we need to do an operation that is going to clear out this material. Now there's some really good features within Fusion 360 that will speed up the process of clearing out a pocket, but also mean that it will clean out quickly. So we're going to go into a 2D operation and we're going to do adaptive clearing. So the first thing we do is change the tool. We're going to go back to our downcut tool. Let's select that. And now I'm going to choose stock contours. And we're going to, we want this, this, and this. In fact, let's get rid of that. It's that down there. Ah. Cancel. Let's get rid of these a moment. I think there's been an update. I think Fusion's updated since I've done this. Okay, so let's click OK to that. No selections. Yes, there has been an update. This is not, this is not. Start on the inside, click on OK. No selections. Do I have to select these individually? Looks like I do. 2D adaptive. Downcut bit. All right. So the geometry is going to be stock contours, inner loops, start on the inside. Can I select these and then click OK? Is it gonna allow me? No, no selection. But if I do them one at a time, no. All right. We're learning as we go here. Okay, we're doing a climb cut because we're inside the material, and if you're doing a climb cut when you're inside the material, you don't get any breakout. But if you're on the perimeter going around it, you do the conventional milling in the anti-clockwise direction because of the bit rotation. You don't get breakout on the outside. So let's have a look. Passes. Stock to leave. Do we want to leave any material? And I'm going to say no. We're not going to leave any material. Let me see. Multiple depths. So I'm going to go down in steps of 15 millimeters. And that is based upon the amount of material, the amount of cutting edge that I've got on my bit. And we can come back and tweak this at a late stage. No pocket selected to machine. What's this then? This is not being helpful. This is not being helpful at all. Okay, so cancel this a moment. We got a pocket there. Got a pocket there, pocket there. Have they updated it so that it's just... In the previous iteration, when I was just practicing this out, I was able to select the model surface, and that doesn't seem to be what I'm able to do now, which is not helpful. All right, we seem to have something. Okay, I'm reasonably happy with what I'm looking at, with one exception. This neck pocket doesn't need to protrude all the way out here. Right? So there's a lot more machining going on in here than needs it. But while we're here, let us simulate. I just want to see what this actually does in terms of the adaptive movements. So there's the first pass. Okay, it is doing this in 2 passes. All right, so we can exit the simulation. Now, let's go back in here and edit. Just choose the geometry, and you can see it's stock contours. I wonder if I can select the bounds under which this is going to operate. Maybe that's what's going on. Now that's more like it. Okay, so what we did is we defined the pocket that it was going to cut out, and we actually constrained the operation within the body of the guitar itself. So that's good. All right, so let's simulate this. So you see the stock being removed. That's perfect. Okay, and then it's going to move on to the pickup pockets. And then it's going to move into the control pockets. Awesome. Okay, we're almost finished with this particular setup. So if we exit the simulation, the next thing that we need to do is this arm bevel. Now this arm bevel we're going to do in 2 passes. The first pass is going to be a rough pass. Let's do that now. And we're going to use a... Let's have a look. What do we got? We got a contour cut. So we're going to select the tool. We're going to use the down cut bit for this. And what we're going to do is we're going to remove the material, like bulk material here. And this is where we're going to come into a problem, because I thought I'd removed these radiuses. What have I forgotten to apply that somehow? Okay. No. I need to save that file. So now I've saved this file, the design file. I come in here and I get an exclamation mark telling me that my model is out of date. So if I click this little... It would seem that I had a microphone malfunction. That's the first time I've had a drop out of the microphone like that. Okay. But it wasn't a mute. Interesting. Some very strange things happening on this stream tonight. There we go. I don't know how long I was out for, but... Okay, we got an error. Parameters, toolpath. No passes to link, empty toolpath. Okay, so we've got an issue selecting our geometry, so I'm not quite sure what is going on here. Okay, let's choose a silhouette, and we're going to... I rebooted the microphone. But yeah, I'm not quite sure why that did that. Okay, we choose the model surface. There we go. There we go. Okay, it's still not happy. Okay, for some reason, it's not generating this. It's not generating. There we go. So now we've got this like stepped effect. So if I simulate this and we press play. Wonderful. So now what we're going to do is exit the simulation. And we're going to do a parallel cut. This time we're going to use a different tool. We're going to use a ball nose bit. And this ball nose bit will leave us with quite a nice finish. Okay, so what did we do here? We chose the model. Don't include the model. We select that and we click on OK. We should hopefully get a nice, there we go. And let's simulate that. So you can see we've got these stepped. And in comes the bit and it clears that out so that that's a nice smooth transition. This will probably need a very fine sanding, if that. That is my hope. We shall find out. Okay, we can exit the simulation. We now have the front of the guitar all dealt with. So if I rename this setup, let's have a look. Can I rename it? I should be able to. There we go. We'll call this front. Like so. The front is done. So what we're going to do now is we're going to right-click setups and create a new setup. And we're going to flip this upside down. Let's get this orientated the way that we want it. So this is now flipped. And we're going to bring our CNC bed back. We want selected point. Kind of forgotten it already. What did we do? Can you remember? Stock box point. There we go. That's what we want. Okay, so I'm gonna just. You'll notice this is like the Z is in the positive going down. We need to flip this. So if I click on the Z, I want to be able. Okay, that's the model orientation. So select Z axis and Y axis plane. See if I can do that. Oh, there we go. There we go. So we've now got Z, positive Z going effectively what will now be down. Y is positive Y is in like that direction going up, and across is the X. So that's the same as we had in the first instance, right? So cool. We click on OK now. No model selected. All model size will be used if you're going to use the warning. Let's ignore the warning for a moment. There we go. That origin is in the right place, so I'm not overly concerned about that. Okay, so we've got two operations really that we need to do. First of which is getting this belly cut out, and then we need to cut out the perimeter. So the first thing we're going to do is a contour cut again, 2D contour, and we're going to go back to our down cut bit, like so. We're going to go to our geometry. And we're going to select that. I'm going to click on OK. Okay, spot the obvious problem. I chose a contour. That's not what we wanted. It's 2D contour, right? No. 3D contour. That's what we want. Yeah. So let's go back and select the tool. See, this is repetition. This is all repetition. You don't do it very often. It fades away pretty quickly. Okay, so we're going to model selected surfaces. We're going to remove the initial include setup. We're going to click on OK. We should hopefully get our step. We do indeed get our stepped cut. Let's simulate that. Now we're going to play that simulation. And you can see we're just cutting in a stepped fashion down and down and down. Now I might need to adjust. There's a couple of crashes here that we need to potentially, be concerned about. But we'll see. We'll see. We may need to put a relief cut in here to remove this material first, but we shall see. We shall see. Right. So now we've done that, we can exit the simulation. We can now come in here and do a parallel cut, 3D parallel cut. And we're going to change the tool to our ball end mill. Select that. We're going to come in here and we're going to choose the model, choose that face, exclude the setup model, click on OK, and we should hopefully, there we go. We've now got this nice fine-tuned toolpath. Let's simulate that. Okay, this is looking good. We can watch what the machine is doing the whole time, right? So this is really good to do to spot errors. If you're able to run the tool path in the machine, sort of in the computer before it gets to the machine, you can spot some issues before they become real problems. All right, so now the final thing that we need to do is exit the simulation. We need to do a 2D contour. So the 2D contour essentially is going to free this from, it's going to liberate it from the material. So we selected our 2D contour. We got all of it. No, it's not closed loop. So let's close the loop like so. The tool we're going to use is going to be the downcut tool. And let's select that. We'll click on OK. No contour selected to machine. OK. We'll choose that then. There we go. And now let's simulate. And just make sure. Okay, so straight away we got a problem because we've just cut out our neck pocket. That's not a good thing, right? So let us exit the simulation. We need to come back in here. We need to edit the tool. And let's get rid of that for a moment. And we're going to do a chain. There we go. I think we're going to be good using that option. And we're going to go to the passes. I'm gonna be gentle on this. So we want to do multiple depths. And I think we're going to go down in depths of 7 millimeters at a time. I don't want to be too don't want to be too aggressive with it. So safe distance. The safe distance is higher than the feed height. Consider reducing the safe distance, otherwise the feed height will be raised to match the safe distance. Okay, that's fine. It's going to take care of it. All right, so let's have a look at this now. If we simulate. All right, so that's now going to cut out the neck pocket. And it did it in 1, 2, 3 passes. Ah, okay, it didn't go all the way. It did not go all the way through the material. So let's exit simulation. We've got an error here. What's the error? Oh, it's the safe distance. Okay, perfect. Edit. Okay. Passes. Maximum roughing. Don't see a depth. It's only going down to this point here. We want it to go to the full depth. Well, look. Okay. Bottom height. Stock bottom. Click OK. There we go. And fixed. Okay, so we're now cutting all the way through. So if we right click here and simulate. We cut all the way through. We've liberated the body from the blank. We're going at a nice steady pace. We're not being too aggressive with the bit. And that is perfect. That will give us a completed body ready for routing and sanding. And we could then start looking towards machining designing and machining the neck. So that brings us to the end of today's stream. Just to recap, we took the body. We were then able to represent our blank that we're going to use on the CNC machine. We machined 4 boring holes that we're going to use for location. But I'm going to use that operation in 2 places. One, to clear out the holes for the material itself, but also to bore the holes on the bed of the CNC. And we'll use those for location so that when we lift the body up and flip it over, we can then drop it down and have a perfect sort of match when we machine the back. So then we went through setting up the face, the front side of the bass, and we did a surfacing pass to make sure that the surface is flat. We we then did a pocketing operation to cut the holes for the neck pocket, the pickups, and the controls. We then did a contour and parallel cut to then machine the arm bevel. And then flipping over, I did notice that we didn't do a surfacing pass, but essentially we'll repeat the surfacing pass first so that it's all nice and parallel before then going on to do the contour and parallel cuts for the belly cut. And then finally, we did the pass for the contour of the bass just to pop that out. And as I say, this is theoretically what the bass is going to look like once it has been completed. So, without any further ado, I will bring this live stream to a close. If you have found value in this, please hit that like button. If you are not already subscribed and you would like to see the journey of the Fender Jazz Bass as we progress through the build, go ahead and hit that subscribe button. And I will see you guys in the next video. Take care. Bye for now.